Hello, class. Welcome to our lesson today dealing with section 10.6. Today we're going to be looking at the beginning of samples and populations. Before we do that, I just want to review a few questions about percentages. Remember, you could do the equation or the proportion as you're going through these situations. I chose to kind of read from left to right and think about what the part and the whole and the percent are. So this says 72% of what number is 576? 72% of is multiplication of that number, so that's times x equals 576. Solve for x by dividing by 0.572 on both sides. You should end up with x equals 800. You could also do a cross multiplying technique with the part over the whole equals percent over 100. Either one of those options will get you to your answer. On the next one, what number is 0.5% of 450? Most common mistake is people try to take 0.5 of 450, but it's 0.005. And so you got to make sure that you multiply those two pieces together to get 2.25 as your final answer. And so 0.005 times the 450, and then figure out kind of what that part would be. And it should be really small. If you think about it, you're only taking half of a percent of a number. So it makes sense that that number is so much smaller than the 450. Okay, today we're going to be looking at some definitions of population and sample. So a population is the entire group of whatever subject you're talking about or people that you're looking at. Remember, population is not every person in the world, because if the population is only that specific area, then that's the area that you care about. A sample then is a portion or a part of that population. We use samples typically because populations are hard to keep track of constantly. For example, we don't take the census every year in the United States, we take it every 10 years. Even with technology and new improvements about how to collect the data, it still takes a lot of work, time, and effort and money in order to do that. So instead, we typically take samples of the data and then make a conclusion or an inference based upon what we find of that population. So here's the idea of what you want to do. If you're going to collect data, first thing is to identify the population you care about. So if I want to do something about the school, I would just say, okay, the students in the school are the population. After that, I would select a sample. I would find some way to figure out how to collect some data on certain people or groups of people or randomly selected people, and then collect that data. Once I collect the data, I interpret what the results are telling me. And then after that interpretation, I say, all right, based upon what I found, this is what I think will happen. So the idea is kind of similar. You can think of it kind of like the scientific method, but it's for probability. And that's the basic thought process behind a lot of collecting data situations. Here are 4 examples of different situations. We just want to make sure we're able to identify which is the sample and which is the population. So this first one, the students in the school, is the population because the students in the math class are a portion of the students in the school. The grizzly bears in the park are the population of letter B, and then the ones with the GPS collar for tracking purposes would be the sample of that population. For the quarters idea, all the quarters in circulation would be the entire group, but then the 150 quarters that you have, for example, would be a sample of that. All the books in the library would be the population, and then the 10 books that you have, or the 10 books that are on a certain shelf, for example, would be the sample. You can kind of think of it which one's larger and smaller, but the sample should correlates in whatever reason, in whatever way to the population as well. So that's something else to think about when it comes to these scenarios. The best way to collect data is to use random sampling. Random sampling is done in a lot of different ways. Honestly, the best way to do random sampling is assign everyone a number, and pick a random number generator on a computer or something, and pick the number, and then say, all right, we're asking person number 7 to come forward, and we'll ask them those questions. The goal with random sampling is it takes biased nature out of a lot of things. We inherently have some biased nature whenever we do a lot of things, especially collecting data. So the best way to take care of that is to do a random sample. We could do that with the random number generator. We could just pick names out of a hat. There's lots of different ways that you could do that. The key, though, is there's a lot of bad ways to collect data. All right, so we're going to go through a couple of those options here today about some good ways to collect data and also some bad ways to collect data, and see if we notice anything. All right, the next 3 slides talk about building a new power plant on the outside of town. Residents of a town are asked about the new plant, determine whether the conclusion that was developed was valid, and then explain your reasoning. Now, if this was a homework question, the anticipation would be you're going to write a sentence or two. you should be able to explain. It's going to take a paragraph probably in order to explain what's going on in a lot of these cases. A radio talk show gets calls from 500 residents. The table shows the results. The radio station concludes that most residents of the town oppose the new plan. On the surface, this appears to be true. If you look at the data here on the left side, it appears that most of the people in the town are against the power plant. The problem is this is not a random sample. Anytime something is voluntary response, which means someone calls in or a mail-in survey or anything like that, that automatically has some biased nature to it. This radio show could have a particular political slant, for example, and that's why people watch it. And so, of course, there should be some correlation to the viewers of that show, most likely, or the listeners of the show on the radio, about what their thoughts would be about the power plant. So while the company or the talk show can say, well, this is what we found, it may not reflect what most of the residents would say. Now, if you change the result to say most of the viewers of the show or the listeners of this radio show, maybe that could be a valid conclusion because your population is different. But you can't make a generalized statement based upon a voluntary sample and a voluntary response. The next one says a news reporter surveys 2 random people outside a supermarket. The graph shows the results. The reporter concludes that the town is evenly divided. The most obvious issue with this is you only ask 2 people. Now, I'm not saying that there's a set number of people that you should ask a question to, but 2 is too small. So we want a higher sample size, more people that we're asking the question to. Some people would say outside the supermarket is also an issue. That's actually a better random sample because all groups of people will go to the supermarket at some point. So that could be a random sample, but you have to make sure that you're paying attention to going to the supermarket at different times and different days and things like that. You don't want to be going at the same time every day. Maybe there's a senior discount in the mornings, and so if you're there on a certain time of day, you get more senior citizens versus like college-age kids. Those are some things that you want to look at. But the main issue is you only ask 2 people. You shouldn't be basing a response on 2 people. The next one says you randomly survey 250 people at the shopping mall. The table shows the results. You conclude that twice as many people in the town are against the plant than for the plant. Of the 3 options, this one's the best one. I would say you probably want to go to different areas, not just the mall, but the mall does have an interesting mix of people and a good representation maybe of much of your population, especially if depending on how big the town is. I would say probably a mixture of going to the mall, maybe going to the supermarket, maybe by a post office, going to a couple different places and collecting data and bringing it all together might be helpful. You want to do that at the same time to make sure you don't double count someone. But it does appear that about significantly more people are against it than for it, about twice as many. So that part is probably true. The shopping mall itself may have an issue if you only go to one area, but you did randomly survey people. So that's a good thing. But there are some issues that you want to make sure you're paying attention to when it comes to this scenario. Of the 3, though, this is the best of the 3 so far. Again, I would probably say to improve this, we should maybe go to other areas than just the shopping mall to get a good cross-section of what our town would be saying. Think about what we just looked at. How can you determine whether a sample accurately represents the population? Well, the best way is to know what the population is and then randomly select people in that population to come up with a conclusion. Does increasing the sample size make it more representative? It should be, as long as it's done randomly. However, if I want to ask people about being left or right-handed, if I single out all the left-handed people, increasing that sample size doesn't help because I'm only asking a specific part or a biased group of that population. So as long as it's done in a random situation and in a random sample, if you increase the sample size, it should start to correlate more and more closely to what the population would actually be doing. This would be similar to tossing a coin. If I toss a coin 3 times, I could get heads all 3 times, or I could get tails all 3 times. If I toss the coin 100 times, I'm probably going to get closer and closer to what I expect to happen. And that mindset is similar when you collect data of a random sample. Okay, your homework here has just a few questions that you have to explain yourself on 3 and 4. On 20 through 24, try those questions without a calculator. Okay, make sure you show your work on those questions. We're going to be looking to make sure that you've done that. Also, make sure that you write down the definitions of unbiased sample and biased sample for your notes. All of that can be on one page. We're going to use that unbiased and biased sampling definition in our next lesson. Have a good day, everyone.